right, so as you can see for this section, I've combined 7.1 and 7.2 into one section. It's all about inverse trig functions. So let's look at a definition here. So y equals inverse sine of x is true if and only if sine of y equals x, and this is very important, your x is between negative pi halves and positive pi halves. So here's the bottom line. When we look at our inverse functions, and we're only going to do sine, cosine, and tangent inverse, what we have to do is we have to restrict the domain, and you can see the restricted domains for each one of these. And we need to restrict the domain because, as you know, if we didn't, for example, sine would keep going on like this. And when we were to find the inverse, what would happen is it would no longer be a function. How do I know that? Because if I keep going, it doesn't pass the horizontal line test. Remember, if the inverse is also a function, it means that your graph has to pass both the vertical line test and the horizontal line test. So what we have to do is we have to restrict the domain and only use a very small portion of the graph when we are dealing with inverse functions. And I'm going to show you some examples, and we're going to do it very slowly as we go through. So, for example, if I just, and we're going to do the example down there, but for example here, if I just take this little part of the sine function, do you see that it passes both the vertical line test and it also passes the horizontal line test? And this is the portion of the sine function from negative to positive pi halves. As soon as you were to keep going further, it's going to start failing the horizontal line test, which would mean that its inverse would not be a function. Okay, so that's basically what we're saying is we have to, when we talk about the inverse functions, we have to go with these restricted domains. And these are going to be important for the rest of the course. Okay, so for sine, that restricted domain is from negative pi halves to positive pi halves. Notice it's bracketed, so it's inclusive. Okay, when we talk about inverse cosine, is true if and only if. And by the way, how are they getting these? If I were to take this and just take the cosine of both sides, so it'd be cosine y equals the cosine of the inverse cosine of x. See how these would disappear because you're taking the cosine of the inverse cosine. You're doing two opposite operations, and you would just get x equals cosine y. So that's how they're getting this. More importantly, though, for you, the restricted domain for cosine is going to be from 0 to pi inclusive. And then for tangent, the restricted domain is going to be from negative pi halves to positive pi halves. And notice that that is parentheses. That does not include negative pi halves and positive pi halves. And I bet you can guess that is because that's where you have two asymptotes. All right, so we're going to go through these notes fairly slowly because I want to develop this for you. And since we're only doing 3 of the 6 trig functions, I thought we would have time. So we are going to, again, do those very small, the parent graphs. And the first one we're going to do is y equals inverse sine. Now, let me also say that another way of writing this is y equals arc sine x. Or another way of reading this would also be y equals arc sine x. And I'm going to tell you that because sometimes I say arc sine. When I say arc sine or arc cosine or arc tangent, it means the same thing as inverse sine, inverse cosine, inverse tangent. Okay, so if we go ahead and we're not going to do the inverse quite yet. We're going to save that for the second graph over here. So if we go ahead and if we graph our sine function with our restricted domain, so we're going to go from positive pi halves to negative pi halves. And this is going to be 1, and this is going to be negative 1. So you can see our domain is from negative pi halves to positive pi halves. That's our restricted domain. And of course, if we graph a couple of points, the sine of 0 is 0, the sine of pi halves is 1, and the sine of negative pi halves is negative 1, because that's in the fourth quadrant. So our sine function with our restricted domain looks something like that. So it's only a very small part of the actual sine graph. And notice the range is going to be inclusive from negative 1 to positive 1. Okay, so now what we're going to do to look at the graph of inverse sine is remember how we flip the domain and the range. So as we flip the domain and the range, our y-axis is going to become our x-axis, and our x-axis is going to become our y-axis. And we're going to flip the domain and the range. So 0, 0 is still going to stay the same. Now remember, this point over here would be pi halves 1. So we're going to go 1 pi halves. And then this point down here would be negative pi halves negative 1. So we're going to go negative 1 negative pi halves. Now, if you just look at those points, it looks like a straight line. So you got to make sure you get your curve going in the right direction. Remember, it's part, so if you tilt your head, you'll see that it's going to go this way. It's got to be, if I flip it, which I'm going to do, if I flip it and look at it this way, it should look like part of a sine graph. If I just flip my paper 90 degrees. So you can see that the domain is from negative 1 to positive 1, and the range is from negative pi halves to positive pi halves, which should make sense because remember, all that happens with our inverse functions is the domain and the range. They flip. Okay, so we're going to do something similar for both cosine and tangent. So for our cosine, and again, for cosine, our restricted domain is from 0 to pi. That is a part of the graph that would make both the graph vertical line test ready and horizontal line test. So we're going to put a pi halves here and a pi out here, and of course that's 0. We're still going to go 1 and negative 1. So if we look, the cosine of 0 is 1, the cosine of pi halves is 0, and the cosine of pi is negative 1. Now remember, it's part of a cosine curve, so it's not a straight line. It looks something like that. Notice it passes both the vertical and the horizontal line test, and the range is going to be from negative 1 to positive 1. All right, so now let's go ahead and let's flip it to do the inverse cosine graph. So again, our x and y axis are going to flip. So this is going to be pi halves, and this is going to be pi. So if we look back at our graph, this point right here is 0, 1. So I'm going to go 1, 0. It's going to go through the y-axis at pi halves, and this point is pi negative 1, so we're going to go negative 1 pi. And again, make sure when you graph it that you get the curve going correctly. Don't make it go like this. If you went like that, it wouldn't look like the cosine function when you flipped it. So your domain is obviously negative 1 to 1, and your range is from 0 to pi because it's the domain and the range of the regular cosine graph with its restricted domain. All right, well, let's finally go ahead and let's do the tangent graph. So remember, tangent graph goes from pi halves to negative pi halves. And remember back when we first graphed tangent, I centered that one period around the y-axis. I did that for many reasons. One of them is so you could get a complete graph of a branch, and the other one because I knew this was coming and I knew the restricted domain for the tangent. So hopefully you remember that there are asymptotes at negative pi halves and positive pi halves. And of course the tangent of 0 is 0, the tangent of pi fourths is 1, and the tangent of negative pi fourths is negative 1. So basically, that restricted domain gives us that one branch of tangent. So the restricted domain goes from negative pi halves to positive pi halves, and it doesn't include the asymptotes. What's the range? It's going to be all real numbers. Because remember, tangent does not have an amplitude. So now when I flip that, when I go to do my inverse tangent, so we're going to have a 1 here and a negative 1. And this is going to be positive pi halves, that's pi fourths. And this is going to be negative pi halves, and that will be negative pi fourths. Our vertical asymptotes become horizontal asymptotes. Everything is flipped. It goes through the origin. Now this point right here is pi fourths 1. So we're going to go 1 pi fourths. And then we're going to go negative 1 negative pi fourths. And you can see that it's going to look like that. So now the domain is all real numbers. And the range is from negative pi halves to positive pi halves. Okay, so there you've seen all three of the graphs. For the regular graph with a restricted domain, as well as for the inverse functions, which we just flipped. Okay, so now remember when we talked about the unit circle, and in fact it was during the unit circle video, I said that you really have to know that unit circle going forward, because when we do chapter 7, which we're starting, you have to know it backwards. And here's what I meant by that. So it says find each value in pi radian measure. So we're going to talk radians. Have your graphing calculator, by the way, handy because we're going to need it for number 5. Okay, so I want the inverse sine of root 3 over 2. Here's what that means. Read it this way. What angle, so this time I'm looking for the angle, has a sine of root 3 over 2? What angle has a sine of root 3 over 2? So first thing you have to remember is the sine restriction is from negative pi halves to positive pi halves. In problems like this, it means your answer has to be either in the first or the fourth quadrant. So since our value is positive, we're going to be looking for a first quadrant angle. So what angle in the first quadrant has a sine of root 3 over 2? Well, that's going to be pi thirds, 60 degrees. Look at your unit circle if you need to, but hopefully you shouldn't need to, because I know you should know your unit circle. You've all had trig before, so they should have pounded that into your head. Look at this one right here. What angle has a cosine of negative 1? The only angle that has a cosine of negative 1 is pi. All right, we have to be careful with C. So again, this says what angle has a tangent of negative root 3 over 3. So now remember, tangent is restricted also from negative pi halves to positive pi halves. So we have to be talking about either a first or a fourth quadrant angle. Because my value is negative, I'm talking about an angle in the fourth quadrant. So when it says what angle has a tangent of negative root 3 over 3, well, I know that my 30-degree angle or my pi 6 angle has a tangent of negative root 3 over 3. I need to have it in the fourth quadrant, so I'm going to call it negative pi 6. Okay, they don't want you to use 11 pi over 6. They want you to call it negative pi over 6, even though they mean the same thing. Okay, you're going to call it negative pi over 6. So any angle that you're talking about in the fourth quadrant, and that's the only place it's going to happen, you're not going to name it this way. You're going to name it as a negative angle going down clockwise. Let's look at D. What angle has a sine of 0? Well, now again, if we think about that, it has to be here, between here and here. Now there are actually two angles that have a sine of 0, pi and 0, but since pi is out of our range, our answer is going to be 0. So each one of these should only have one answer. If we look at E, now here, look, I wrote it as arc cosine. Just so you know, though, that means the same thing as that. So now remember, cosine is restricted between 0 and pi. So our angle would have to be either a first or a second quadrant angle for cosine. Okay, well, because my value is negative, cosine's negative in the second quadrant. What is that angle that has a cosine of negative 1/2? It is 2 pi over 3. Again, I know that because I know my unit circle. What angle has a tangent of -1? Remembering that tangent has to be either first or fourth quadrant. That means this has got to be a fourth quadrant angle. It's going to be negative pi fourths. What angle has a cotangent of √3 over 3? Now another way you could think about this would be what angle has a tangent, and if you flip this and get the radical out of the basement, you're going to get a √3. So maybe that's a little bit easier for you to think of. What angle has a tangent of √3? It's got to be a first quadrant angle because the value is positive, and it's going to be pi thirds. We could do the same thing here. If you are bad with your reciprocal functions, you could say this is really arc sine of -1/2. So what angle has a sine of -1/2? It's got to be in the fourth quadrant because it either has to be first or fourth, but since this is negative, it's got to be fourth, and it is negative pi 6. All right, I'm going to stop this video and go on to part 2.